All right, ratio and proportion. Things you've done before. A comparison of two or more quantities. To represent a ratio, there's several different ways we can do that. The most common way that we use is fraction, like A over B. But you could also use, y'all remember the colon in between the two things? That's also a ratio, just a different way of writing it. And then the other way that you commonly see is A to B is a ratio. Ratios can be simplified because they're technically fractions. So when we do a ratio, we want to simplify that as much as possible. We may use that. So when we get into similar figures, sometimes we can use the simplifying to help us make the problem a little easier, smaller numbers to deal with. Okay. All right. Example here. Let's write some ratios real quick. Music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write each ratio in simplest form. So trumpets to violins. I'm going to write my ratios in fraction form because that's how I like to do it. So trumpets to violins. So how many trumpets do we have? 40. How many violins? 24. And we're going to reduce that to be 5 over 3. And that would be the simplified version of that. So 5 over 3. It would be the same thing if you had 5 colon 3. It'd be 5 to 3. Or 5, let the word 2, 3. It's the same thing. I like to write them in fraction form. That's just the way I'm built, I guess. Flutes to clarinets for number 2. How many flutes do we have? 51 clarinets. 39. Both divisible by 3, so 17 over 13 is the simplified version of that. Number 3, trombones to trumpets. The brass section here. Trombones on top, so that's 16. And, 2/5, 2 to 5. Okay, violins to total instruments. Do a little bit of math here. How many violins do we have? 24. How many instruments do we have? 90. I'm getting a lot of different numbers here. 170 is the correct number. And then we reduce that. They're both even, so that's going to be 12. And then 85. And then 8 and 5 is 13, not divisible by 3. 12 is divisible by 3 and 4. 4 doesn't go into 85. 6 doesn't go into 85 either because 3 doesn't go into it. So that's as simplified as it gets. All right. Easy stuff, right? Heck. All right. Extended ratios. It's a comparison of 3 or more quantities. So normally a ratio is just 2 numbers like the examples we did there. But when we get into talking about figures, we've got multiple sided figures. We talk about triangles, some quadrilaterals today and stuff too. So we have more than 2 sides that we're going to have in ratio here. So the extended ratios are written usually in the colon notation. That's normally how extended ratios are going to be written. And then we're going to apply that to some different figures and geometric principles. So we're going to get actually into some geometry and out of the music store. So number 5 asks us the ratio of 2 complementary angles is 3 to 7. What's the measure of both angles? So complementary angles, what do we know about those? they add up to be 90, right? If the ratio is 3 to 7, then 3x plus 7x would equal 90. We don't know how much x is, but we're going to find out. So 10x equals 90, x is equal to 9, and the two angles are 27 degrees, and 7 times 9 is 63 degrees. So applying it to geometric idea. So if angles are in ratio and they're complementary, this is kind of how you're going to set that up. Number 6 is a supplementary problem. Same idea. 4 to 1 with the measures. What are the measures of both angles if they're supplementary? So what's our equation? Yeah. And then y'all know that's 5x equals 180. Divide by 5 would be 36. So we have 36 degrees, and the other one would have to be 144. So add up to be 180, right? Also, 4 times 36 is 140. Okay, so we're using that ratio and the supplementary idea to get there. Number 7, the ratio of the measures of the angles of a triangle are 4 to 7 to 9. So we finally have an extended ratio that has 3 things in it. Find the measures of the angles. So it's inside of a triangle, so what do we know about those? They add up to be 180. So 4 times x plus 7 times x plus 9 times x equals 180. And 16 and 4 is 20. X is 9. So the ratio, the angles would be 4 times 9 is 36. 7 times 9 is 63. And then 9 times 9 is 81. Those are our 3 angles. Pretty easy stuff. This is ratios are boring. Number 8, the ratio of the measures of the angles of a triangle are 11 to 2 to 5. Find the measure of the largest angle. We know they add up to be 180. Set that up. 16 and 2 is 18. X is 10. So the largest angle is 110 degrees. They asked for the smallest angle, we'd have 20 degrees. They asked for all 3 with 5. All right. Number 9 says the ratio of the measures of the sides of a triangle are 2 to 8 to 9. If the perimeter of that triangle is 76 inches, find the length of each side. Yeah, so 2x plus 8x plus 9x equals 76. 11 and 8 is 19. And I bet 19 goes into 76. Close to 20 and 80, so I'm going to guess 4. 4 times 10 is 40. 4 times 9 is 36. That has to be 76. So x is 4. And then we find the sides. So what are the lengths of the sides? 8 what? Inches. We had a dimension, so we're going to use the dimension in it. They told us it was inches. If they don't tell you the what kind of unit you're dealing with, you don't have to write it. But if they tell you, you need to write it. Number 10, ratio of the measures of the sides of a triangle are 10 to 15 to 6. The perimeter of the triangle is 217 meters. Find the length of the shortest side. Same setup. It's like the easiest algebra you'll do today. 25 and 6 is 31. X is how much? 7. And then the shortest side would be, yeah, the 6. 42 watts. Easy stuff. Easy stuff. All right, let's channel our inner 8th grade math skills here to do the proportion stuff. So an equation that states two ratios are equal is what a proportion is. So the definition of a proportion is an equation that states two ratios are equal. The proportion is written as A over B equals C over D. So you set the proportion up. And the cross product property, we usually say cross multiply to solve. It's the same thing. Cross product, cross multiply. Remember, product and multiplier are the same thing. To find any proportion. So it's A times D, B, and C times B, or B times C. Let's do alphabetical order there. Keep our OCD in check. And you solve it from there. So really easy ones. We're not going to do all these at all. We're going to do 6 of them. So let's do number 11. Pretty easy one. Cross product. Bottom times top, bottom times top. So that's 2x is equal to 28. X equals 2. This should be the easiest stuff. Number 13, let's do that one. You're just going to go down the odd side there. So what do we do there? Which is 19x minus 19 equals 13 times 6, which is 78. Good job. And then we add 19. So that'd be plus 20 would be 98, but it's 19, so it's 97. Divide by 19. And it doesn't go evenly, does it? 97 over 19. It's like 5.1. I would like for you to just leave it as fractions. I think the answer key on the homework converts to decimals, but I would prefer just leaving them as fractions for me. But 15. Cross product. Okay. 40x minus 180. 40x is equal to 270. I know that'll simplify to be 27 over 4, which is a decimal is what? 6 times with 3 leftovers, or 6.75. Again, I prefer the fraction form of that, but there may be times we may need the decimal form for whatever purpose. 17, got x's on both sides. It's not any harder. So 18x minus, what's 20 times 18? 360. 3x minus 33. Solve that, dude. So it's going to be 15x is equal to 327. All right, and then divide. 3 and 2 is 5, and 7 is that. What's it as a fraction? 109 over 5, and it reduced it, and that's 21.8. You said that's good. Good job. All right, 19 and 20 are where you get to decide how good your algebra 1 teacher is. Because what happens when you do the cross product here? Yeah, you get x minus 1 times x plus 5 equals 5 times 27, which is 135. And then to solve that, you got to multiply this out. X squared plus 4x minus 5 is 135. So you're just distributing the x and then the -1, and then the 5, x times 5 is 5x, Positive 5 and negative 1 is 4. Negative 1 times 5 is negative 5. And then to solve that, what do I have to do?
No, you do the thing you go over.
No.
Never mind. Right?
If I'm going to use factoring, what do I have to do first? Get it equal to 0, right? If I'm going to use the quadratic formula or factoring to solve this, both of which are valid methods for doing this, I've got to get it equal to 0 for either one of those ways. Okay, so I'm going to move the 135 by subtraction. So x squared plus 4x minus 140 is equal to 0. And multiply to be negative 140 and add to be 4. 14 and negative 10. And I can use the shortcut here because there's nothing in front of x squared. So it's going to be x plus 14 and x minus 10. Set each of those equal to 0. Negative 14 is an answer. And positive 10 is an answer. Yeah, it's been a minute. Yeah, like since last semester. Some of you, it's been a little longer since if you didn't have algebra 2 in the fall. It's been a minute since we did that. All right, let's look at number 20. A little tougher. So we got 2x plus 5 times x minus 6 equals 7 times 6 is 42. Multiply out the left side, so that's 2x squared minus 12x plus 5x is minus 7x minus 30 is 42. And then no matter if I'm doing factoring or I'm using quadratic formula, it doesn't matter. I've got to get it equal to what? 0 before I start doing any of those things. So subtract 42. So we got 2x squared minus 7x minus 72 equals 0. And you just got to make a choice which way you're going to do it. I like factoring as the way just because it's, quick. You can get it to factor. I think it's faster than quadratic formula. Multiply to be negative 144 and add to be negative 7. 9 and you said negative 16? Yeah, good job. All right, and I can't take the shortcut on this one because it's got something in front of x squared. So I got to go 2x squared. I'm going to do minus 16x plus 9x minus 72. It does not matter. Remember, the middle terms there, when you replace those, it doesn't matter what order they go in. You can put the negative 16 first or the 9x first.
X minus 8.
Okay, so I'm going to factor the GCF out of the first two. 2x, and then x minus 8 is what's left over. And this one you're factoring out of 9. And as Tilly said, it's x minus 8 in both of them. And that if those parentheses right there don't match, you've done something wrong. And then you got 2x plus 9, x minus 8, and you set each of those equal to 0. Negative 9 over 2 and positive 8. If you wanted to do quadratic formula, remember it's x equals negative b plus or minus radical b squared minus 4ac divided by 2a. So if you want to use quadratic formula, you can do that. And it works. You get the same answers if you simplify. So, been a minute since we've factored, so get a little bit of small. It's like one of the few things that we do in geometry where you actually factor. Is with the proportions that we end up doing. But it does come back up when we do Pythagorean theorem a little bit, which is very soon. And then when we do some stuff with circles at the end, factoring's going to come up again. So there's not a whole lot of factoring in geometry, but there's some. So got to hang on to that skill. We do a lot of equation solving, not too much factoring. All right, let's get into actual geometry stuff here and apply this ratio and proportion idea to similar polygons. So polygons with the same shape but different sizes. Okay, that's what a similar polygon is. A polygon is some sort of closed figure. Polygons are similar if these two things happen. Corresponding angles are congruent. The corresponding angles have to be congruent for that to be for them to be similar. The second thing that has to happen is corresponding sides are proportional. Angles all congruent. The corresponding angles are congruent, and then the sides, they are proportional. So the ratio of one set of corresponding sides has to be the same as the ratio of another set of corresponding sides. The ratio of corresponding sides is called the scale factor. If polygons are similar, then their perimeters are also proportional. Perimeters are proportional. So we got that kind of comes up here. All right, so similar polygons, really not the crazy hard stuff, but you've got it's like congruent triangles or congruent figures. You've got the order that the letters are written in matters a lot. So it comes up again. So it wants to know what's the scale factor of triangle ABC to triangle DEF. Okay, so the triangle, if they're similar, the ratio has got to match up. So if the scale factor, we're going to look at the side ratios. Side AB corresponds to which side on the big triangle? AB would be DE because they're in the same spot letter-wise in the statement there. Okay, so we're going to set up that. Why does it do that randomly? I don't know. AB over DE, and that'll be AB is 8, DE is 12, and that reduces to be 2/3. Okay. That's the scale factor. Yeah, that's what you're finding when you do the scale factor. What's the scale factor if it's written the other way? Triangle DEF to triangle ABC. Yeah, it's the reciprocal of that because you do 12 over 8 is 3 over 2. So order that the similarity is written in matters. Not only just in the way the letters are written for the figures, but also what comes first. Okay. Perimeter, the ratio. What's the ratio of the perimeter of triangle DEF to triangle ABC? What should it be? So for triangle DEF, 12 plus 21 over plus 15, 48 over 8 plus 10 plus 14 is 32, which reduces. All right. 12 and 21 is 33 plus, yeah, that's 48. What's that reduce to? 3 over 2. Same ratio. Scale factor as DEF to ABC on the sides is the same on the perimeter. Doesn't follow on the area, but perimeter does. Any linear measurement is proportional. Okay. So So if we did not have one of the sides of one of those triangles, but we knew the scale factor, we know the perimeter is in that same ratio. Okay, so that's what we're headed to with this. All right. Similarity statements. The notation for similarity is just one little squiggle. It's like the same squiggle that's above the congruent mark, but it doesn't have the equal sign underneath. Okay, so it's just that tilde is, I think, what that's called. So valid similarity statements must match corresponding angles and sides. So write a similarity statement for the triangles that we had up above in that last example there. So similarity statement for this could be ABC to DEF similarity. So triangle ABC is similar to triangle DEF. Oops, too far. All right. On this one, we're going to list all the congruent angles and write a proportion that relates the corresponding sides for these particular triangles and based on that similarity statement. So we could do this even without the picture. So the similarity statement is triangle JKL is similar to triangle PMN. So the angles is the easiest part. Angle J is going to be congruent to what angle? P at the corresponding spot. Angle K congruent to angle M, and angle L. Easy stuff. Now, the ratio of the sides. So side JK is in ratio with which side in the other triangle? PM. That ratio would be the same as side KL over what side? MN, which would be the same as side JL over PN. All of those three would be equal to one another with the ratios there. That's what we're looking at. All right. Kind of a funky looking picture. Kind of looks like one of them you saw on Benchmark, I think. There was one that looked like this. A few that look like, yeah, there were several similarity things on there. So triangle XYZ is similar to RYS. So the XYZ is the largest triangle, and RYS is the one that's inside of there. And the angle relationships based on the similarity statement, angle. Yep. Notice what do these sides look like they are? These lines right here. They look parallel. Angle X and angle R right there are corresponding by parallel lines, right? So corresponding angles are what? Congruent. So that there's other things that are going to come into play here. Angle Y is congruent to angle itself. So we get a reflexive thing. So when we think about going toward proofs tomorrow, it's in everything we do. Angle Z is congruent to angle S. All right. Sides. Let's get our side ratios. So XY over what? RY. X or YZ. YS or SY. And then the last one, XZ over RS. Easy, boring stuff. All right, so we got a couple of quadrilaterals here, so extend it to a larger figure. Quadrilateral just means got four sides, and the statement says that JKLM is similar to QRSP. Bothers me that they put the P on the end instead of the front. And does that bother anybody else or just me? Probably just me. Okay. All right, so let's get the angles based on the similarity statement. Angle J, Q, angle K, R, angle L, S, angle M, angle P. Now, so we should have four ratios to deal with here on the sides. So I'm going to start with JK over QR, and then KL over RS, LM over SP, and last one would be JM over QP. All those in ratio.
I was looking at the sides to try to figure that out, but it's just.
Yeah, you can go through the similarity statement there, and you don't technically have to have a picture, as we're going to see, and when we get into our examples here. Number 4 there. All right, let's look at those. Number 4, the figures below are similar with a scale factor of 2 to 3. Find the value of x. So 2 to 3 indicates which one's first. The small one or the big one? The smaller one. Is 42 smaller than x? Because we have a picture here, we can kind of look at that. So I'm going to set up the proportion 42 over x equals the scale factor, which is 2 to 3. Then you just solve it like we did those others. So that'd be 2x equals 120 plus 6, 126. And half 126 is 63. Easy stuff. So we have a picture here on number 5. They tell us a scale factor for the similar figures is 6 to 5. Right, find the value of x. So what would be our proportion that we set up? No. X over 28. Look at the triangles. Which one's bigger? The one with x in it is bigger, right? So it should be corresponding to the 6. Cross multiply. 120 plus 48 is 168. Divided by 5. So x is equal to 168 over 5. As a decimal, that would be 3 with 1 left over. 3 with 3 left over. So 33.6. I'm sure you own a calculator. All right, now we get into a similarity statement and some stuff. Okay, so they give us a picture, and we can look at that and get corresponding sides. They give us a similarity statement. The triangle ABC is similar to triangle DEF. Okay, find the value of x. So we want to set up a proportion for this. Okay, so x is on side AB. So if I say AB, what side does it correspond to? DE. So one side of my proportion has to be x over 25. The other side needs to be the other sides that we know about. So BC corresponds to EF, and we have those. Which one goes on top? 28. 20 goes on the bottom. Now here's where we can make our life easier. What do we know about 28 and 20? We can simplify that, right? They're both divisible by 4. I'm going to simplify that to be 7 over 5. And then do my cross multiplying, just so I got a smaller number to deal with. Not a have to kind of thing, but it can make life easier. So cross multiply those. Get 5x is equal to 175. Divide by 5. 335. And the check on it would be, if I put 35 over 25, does it reduce to be that 7 over 5? And it does. Because the ratio should be the same for the corresponding sides. Looking at number 7 there, we got quadrilateral PQRS is similar to quadrilateral WXYZ. Find the value of x. So where's x? It's on RS. So what does RS correspond to? YZ. X over 32. And then PS corresponds to WZ. Yeah, 75 over 40. And we could reduce those nicely. 8 and 15. And then cross multiply. Still got to multiply 32 times 15 though. 8x is equal to 32 times 15, be 320 plus 150 plus 10. No, 320. How much is 32 times 15? My brain's stopping. 480. Thanks. And then divide 60. All right. This one's got a lot of stuff on it. It's got 2 variables in there. We're going to find the values of x and y. So we've got to set up our ratios here. So they give us a similarity statement. DEF is similar to HJG. So it's not in alphabetical order, so you got to be careful there. So DE is going to correspond to HJ. And to find X, what ratio would I use? So you're saying HG would be DF, so X over 12. And then that would be, and then what would be on the other side? So if you said X on top, yeah, 15 over 9. And then I'm going to simplify that to 5 over 3. 60 equals 3x. 60, not 16. X equals 20. Good. And then let's set up a ratio to find y. Y over 14. Do you swap them or not? No. Should be the same ratio, 15 over 9, or we reduce that to 5 over 3. So once I find that scale factor, I can use it, straight away and don't have to do that. And then 3y is equal to 70, and that doesn't go evenly. 70 over 3 be 23.3 repeating. Again, I like the fraction answers. I like these both diagrams. But we do have a similarity statement that says that triangle JKL is similar to triangle MN or NML. So let's set up, find X first. Doesn't matter. So X is side KL. So it corresponds to side ML, which is right here. So it'd be X over 14. And now I need two sides that both have numbers. Yeah, NM and KJ, do they correspond? JK, NM, yes. So which one goes on top? 40 over 16. Yeah. That'll simplify further. So 5 over 2, so it'll be 2x is equal to 70 again. 35, is that what you said, Brian? How do we find y? JL. And we can use that same ratio or scale factor. Do I have to flip it? Y is on top now because it's from the smaller. So reciprocal on that because it's from the what we're looking for is from the smaller. 90, 5y equals 90. 18. That's right on us there. Questions about that one gets a little higher.
So why did you switch?
The reason I switched it, where did y come from? It came from the smaller triangle. So that I knew my ratio had to be the smaller one had to be on the top because where the y came from. That's how I knew to flip it over. I could have done the same problem, just flipped everything over and had 45 over y is equal to 5 over 2, and I get the same answer. It doesn't really matter if you put the variable on top or not. We're very used to putting the variable on the top part, which is why I did that way. We're, I guess, more accustomed to doing it that way. All right, let's get one that's got some a little more math in it. Triangle AGM is similar to triangle KXD, and that KXD has got some expressions in it instead of just letters. So let's set up and see if we can get something going here. So trying to find the value of x. So if I pick side dx, I could do 36 over x plus 6. That works because GM and XD go together. And then the other side that we have is AG, which goes with KX. That'd be 32 over x plus 3. That'd be fine. There's putting in if you did this upside down, I guess, with x plus 6 over 36 and x plus 3 over 32, it's going to be the same problem. It's legal to do it that way. I like doing it this way because the similarity statement has triangle AGM first. So we put that on the top. It doesn't really matter. Okay. Cross multiply, not really nice to us on the numbers here. So 36. Thank you. That'd be 4x equals 12. And x would, no, I did. That's 108, not 180. You said 108, didn't you? 36 times, yeah, 3 is 84. That's more like it. So 4x is equal to 84. X is 21. I think I need to get checked. Swapping numbers. Things just get on. All right. Let's check out number 11. TLY, triangle Tilly, is similar to triangle check. Or Chuck. Is it Chuck or Chuck? Okay. find LY. So they're asking us to find a particular side.
Well, we have to find it.
Indeed, we do. So let's set up our ratio or our proportion here. So TLY comes first. So I'm going to use that side. So what goes with TL? CH. So 25 over 10. Good job. And I'm going to simplify the 25 over 10 to make that 5 over 2, just so I got a smaller number to deal with. You don't have to do that, but to me, it makes it easier. Cross multiply then, we got 5x plus 25 is equal to 8x minus 2. And we plug in 9 times 4 is 36 minus 1 is, so LY 35. Good job. Questions about that? All right. Whoops, too far. Number 12. It says triangle BNV, smaller, is similar to triangle BRG, the larger one. BR is 4x plus 7. BG is 18. Find the value of x. What's up the problem here? So I'm in my picture here. I didn't do a very good job drawing that. From here to here is 4x plus 7. From here to here, can't draw today, is 18.
So wouldn't the height maybe
Yeah, does that matter? True, it does. Good job. It doesn't matter. 12 over 4x plus 7 equals 8 over 18. Reduce this. Just make it easier. Hold on. BN and BR. Okay, yeah, those connect. And then this is BV over BG. Okay. Cross multiply. 16x plus 28 equals 12 times 9 is 108. 16x equals 88. Is that right? No, 80. 80. Look at the similarity statement. It's in the front. It doesn't really matter as long as you do both sides the same way. It doesn't really matter. And then divide that, x is equal to 5. Okay. All right. On the next pages there, those little extra practice there that you can look through. Let's just do a few of those. I want to do for sure number 8, 9, 10, and 11. So let's start with number 8. Because these are the, I guess, the more difficult ones, in my opinion. So triangle KMZ is similar to triangle KDH. Find x. Okay. X is in KM. So I know I'm going to use that. X plus 8. What's KM relate to? KD. How much is KD?
X plus 29.
X plus 20. How'd you get that? That's right.
I just added the 20.
Okay. Now we need to set up another side.
So,
No. So KZ is 32. Is over 60. Yeah. And then simplify that. That's 16 over 30, which reduces 4. 4 will go into both of those. 8. 4 going to 60 15 times. And then cross multiply. Just make it easier. 8x plus 9 or 29 times 8, 160 plus 72, 232. Right. Is that right? Don't help me out with the calculators. And then 15x, 80 and 40 is 120. And solve that thing. So subtract 120, so that's 112. Subtract 8, 7. And divide. What's x? Just so you know, we did not do that the same way that they did. Like that was originally done. So when you're checking these, when we go to do practice, you may set it up differently, but you still may be correct, depending on what, how you did that. Okay. I like the way y'all set that up. To me, that's the easiest part. All right. Number 9, fun problem. Let's see if we can set it up. AGN supply, and FLS. I don't know what that stands for. All right, so let's set up 24 over x. So AG goes with FL, so 24 over x works. And GN goes with LS, so x plus 7. Oh, man. So x squared plus 7x, 24 times 6, 144. Jeez. Did we? Good news, then you know how to factor. So the x plus 16, x minus 9, that's x equals negative 16, x equals 9. Are both of those answers to this problem?
I don't know.
You tell me.
Negative 16 plus 7 is 9.
Negative 16 plus 7 is 9.
Negative 9.
Then the length of the side of the triangle is
No, so it can't be negative 16.
So negative 16 doesn't work. Does 9 work?
Yes. 9 plus 7 is 16.
So we're going to throw out the negative 16 because we're in the context of a shape. The length of sides can never be a negative number, right? So when you get these answers, you got to check them in there and make sure you don't get a negative length of a side. It may be, you may have negative answers that work. So don't automatically just throw it away because it's a negative answer. Because you may have negative answers that actually do work in the problems, but be careful of that. All right. Let's do number 10 there, right beside it. Similarity statement. CSE is similar to YJE. I'm going to try and find X. CSE is, so X minus 2 is where I'm going to start. Over YJ, or SE, excuse me, JE. It would be over 10. That works. CE. Yeah. CE goes with YE. So that's why it's 18 over X plus 1. And then we cross multiply. So when I multiply those two together, that's what it turns into be. X squared minus x minus 2. So multiplying those two binomials together. If you need to write it out on, my wife had a college professor that she called these happy tomatoes. I'll do it all in red so it looks like happy tomatoes. X times x is x squared. And then x times 1. No, she did it this way. That's the way it was. It'd be 1x minus 2x. Does that not look like a happy tomato? It kind of does. That lady was weird though. She was strange. Smart, but strange. All right. Let's go ahead and do the problem. X squared minus x minus 182. Right. Minus, or multiply would be negative 182, add to be negative 1. What does that? 14. Which one's negative 14, positive 13? So it's x minus 14, x plus 13. So our answers are x equals 14, x equals negative 13. Do we keep both of those, throw both of them out? 14 minus 2 works, 14 plus 1 works, negative 13 does not. It gets us those. That's our extraneous, so we throw it away. All right, one more. Let's do number 11, and we're done. Triangle KLM is similar to triangle PQR. It says the scale factor is 3 to 5. Find the perimeter of PQR. So this is a totally different problem. Talking about perimeter here. So what do I need from triangle KLM? If I want to find the perimeter of the other one, no, wouldn't be equal to the perimeter of that. We need to set up a proportion here, because if the 3x plus 5x is if we know the perimeter of the bigger one. We want to find the perimeter of that. We don't know it, but we do know the perimeter of this one. So we could set up 6 plus 12 plus 15 is 33. Is that right? 27 is 6. Yeah, it's 33 over the perimeter of PQR. We don't know. Equal to the ratio 3 over 5. Yeah. And then cross multiply. 33 times 5. I don't know what that is, but I know that x would be 11 times 5 is 55. So use the ratio, the scale factor that they give you. Similar thing here on number 12. The only thing they don't give you the scale factor, so you've got to find it. So you use perimeter, and then you use 2 corresponding sides to get your scale